In this video, we are going to study Bayes' theorem, which is a very powerful theorem which allows us to calculate inverse probabilities. If we know the following conditional probabilities for all i's, where ai's are events that partition our sample space, then we can use Bayes' theorem to calculate conditional probabilities that are in other direction. So we can calculate any aj given b. Let's take a look at that theorem. So AIs, these are events that partition our sample space. Their union is the whole sample space. They are mutually exclusive. Then we can calculate the following conditional probability AJ given B, using inverse probabilities B given AJ. Let's prove that theorem. So we're looking for probability AJ given B, which is equal to probability of intersection of AJ with B over probability of B. This in turn can be expressed as probability of B given AJ multiplied by probability of AJ divided by probability of event B. Now we can express the following probability of event B using the total probability rule or unconditional probability rule in the following way. So we can represent it as the sum of probabilities B given AIs multiplied by probability of those AIs, which proves our theorem here. All right, now let's take a look at a couple of examples. So we have a biased coin, twice as likely to come up heads as tails is tossed once. So probability of heads is twice as of probability of tails. Meaning that probability of tails is then equal to 1 over 3 and probability of heads is 2 over 3. Since their sum should be equal to 1, right? If it shows heads, a chip is drawn from urn number 1 which contains 3 white chips, 4 red chips. So if our coin comes up heads, then we draw a chip from urn number 1. If it shows tails, then our chip is drawn from urn number 2, which contains 6 white chips and 3 red chips. Given that a white chip was drawn, what is the probability coin came up tails? So we're looking for probability of getting tails given that white chip was drawn. All right, so if we phrase the probability in the following way, we cannot answer that question right away. So we cannot answer the question, what is the probability that coin came up tails if white chip was drawn? However, we know the following probabilities. If we reverse these two, then we are asking a question, what is the probability that we draw a white chip if our coin came up tails? Now this question, we can answer this question This is simply drawing what is the probability of drawing white chip from UR number 2. So let's apply Bayes theorem here. Then this expression is equal to probability of drawing white chip given that our coin came up tails multiplied by probability of tails. There are two events that partition our sample space. Either our coin came up heads or tails. So our AIs that are defined in theorem here are two events, our coin being tails or heads. So what is the probability? We always start by theorem, but so we always start our sum in the denominator in Bayes theorem by copying our term in numerator. So that will be exactly the same as in numerator. Second term is for other events that partition our sample space. So we're looking for conditional probability of getting white chip given that our coin came up heads multiplied by probability of heads. Okay, now let's put in some values. What is the probability of drawing white chip given that our coin came up tails? This is 6/9. Probability of drawing white chip from UR number 2 multiplied by probability of tails. The probability of tails is 1/3 over, I copy down the term in numerator, plus what is the probability of drawing white chip given that our coin came up heads? This is same as drawing white chip out of UR number 1, which is 3/7 multiplied by probability of heads, which is 2/3. Okay, great. Now let's take a look at another example. All right, so according to the manufacturer specifications, your home burglar alarm has 95% chance of going off if someone breaks into your house. All right, so let's define the following events. Event A is an event where your alarm goes off. Or better phrasing would be alarm works. B is an event of your house being burglarized. So burglar is in home. Okay, then the first sentence here, your home alarm has 95% chance of going off if someone breaks into your house. So probability of alarm working, given that your house is being robbed, is equal to 0.95. During the 2 years you have lived here, the alarm has gone off on 5 different nights, each time for no apparent reason. So 2 years, this is 365 multiplied by 2, which is 730. So our alarm has, so the next sentence defines the following probability. Probability of alarm going off when your house is not being burglarized is given as 5/730. So probability of alarm going off given that no one is robbing your house. Suppose that alarm goes off tomorrow night. What is the probability that someone is trying to break into your house? So we are looking for probability of your house being robbed given that alarm has gone off. Okay, also police statistics show that the chances of any particular house being burglarized is 2 in 10,000. So probability of house being burglarized is equal to 2 in 10,000. Okay, great. Now let's quickly derive probability of your house not being burglarized quickly. So this is 9998 over 10,000 then. Great. Now we cannot answer our question for probability, conditional probability in that direction. So probability of your house being robbed given that alarm goes off. However, we know the probabilities that are in reverse order. We know A given B and A given B complement. And two events that partition our sample space here are your house being robbed or your house not being robbed. So we start off by reversing these two probabilities in numerator, probability A given B multiplied by probability of B. We copy down our numerator as the first term of our sum in denominator plus probability A given B complement multiplied by probability of B complement. Okay, now this is known. Probability of B is known. A given, so these two are known. A given B complement is also known. And probability B complement, we've derived it from probability of B.